Right now, look up. There it is, the moon, one piece, gray, quiet, always there, the same face it has shown us for all of human history. Now, imagine a crack, a line splitting straight across it, and then the two halves drift apart. It sounds almost peaceful, a picture from a dream. It would be one of the most violent things you could ever witness, and it would not end in the sky. It would end down here, on the ground, in the oceans, in the length of your day, and the seasons of your year. So let me show you exactly what would happen if the moon split in two. Because once you understand it, you will never look at that gray rock the same way again. Start with the thing nobody pictures. You can't just slice the moon like an apple. The moon is held together by its own gravity, every part of it pulling on every other part, locking it into a solid ball more than 2,000 miles wide. To pull those two halves apart, you have to beat that grip completely, and the numbers are almost obscene. The energy it would take to break the moon in two is more than all of humanity has used in its entire history. Not once, but millions of times over. There is no bomb, no weapon, nothing we could build that even comes close. The only thing in the neighborhood that could do it is an impact. Something enormous, a rogue asteroid, a small planet, slamming into the moon at tens of thousands of miles an hour. Not a clean cut, a catastrophic blow, hard enough to crack a world. So picture that moment. Not a laser, not a neat line, a colossal strike, a flash brighter than anything in the night sky, and the moon shuddering and coming apart. And the real question isn't how it splits, it's what happens next. Because from the second it breaks, a clock starts ticking, for the sky, for the oceans, and for us. In the first instant, it doesn't look like two neat halves. It looks like a wound. Where the moon breaks, the inside is exposed, rock crushed and heated by the impact, glowing red and orange, molten and raw. Two enormous fragments, each still the size of a small world, tumbling away from each other, trailing a cloud of dust and debris the size of the moon itself. For a few hours, the sky would be unforgettable, a shattered, glowing thing hanging over the earth, brighter than any full moon you have ever seen. And it isn't just light. The same blow that split the moon flings a spray of rock and dust back toward us, and days later, it arrives. For a few nights, the sky doesn't just hold a broken moon, it burns, torn by thousands of white-hot streaks, hour after hour. The most beautiful, most terrifying meteor storm any human has ever stood beneath. Most of it burns up long before it lands. Most of it, violent, dazzling, and brief. Within days, the sky clears again. But here's what almost nobody expects. Those two halves do not simply fly off into space, because they still have gravity. Each half is still pulling on everything nearby and on each other. And unless that impact threw them apart with tremendous speed, that pull wins. The two halves slow, stop drifting, and begin to fall back toward one another. The moon, in other words, does not want to stay broken. Its own gravity fights to put it back together, which leaves two very different futures. And both of them are bad for us. The first fate is that they come back, not gently. The halves fall together and collide again, slower than the first blow, but still violent, throwing off even more debris. Over months and years, the pieces pull themselves back into a ball, but not the moon you knew, a scarred, lumpy, reformed world, glowing hot for years before it cools, its familiar face erased forever. Brutal to watch, but survivable. That's the version where we get lucky. Forget that version. The darker path is the one where the halves never come back. If that first blow is hard enough to throw them apart faster than their own gravity could ever catch them, they don't reunite. You don't get one battered moon back. You get two, permanently. And two moons is not twice as nice. It's unstable. Each one tugs on the other's orbit, and on Earth's. Their paths wander. They swing closer and farther in ways a single moon never does. And over thousands, even millions of years, that slow tug-of-war ends one of two ways. One moon is flung out into space and lost, or one of them begins, very gradually, to drift inward, toward us. Follow that one down. Or one of them slowly falling back toward us. But all of that takes ages, and in the meantime, we would live under something no human has ever seen. For as long as those two moons hold their orbits, decades, centuries, maybe far longer, we would live under the strangest sky in human history. Two moons, not side by side like a poster, two separate worlds, moving at their own speeds on their own paths, one rising while the other sets, one full while the other is a thin crescent. Some nights they would drift close and almost touch. Other nights they would sit on opposite horizons, and there would be no true darkness at all, a night lit from both sides. And every so often, they would line up, one moon sliding into the shadow of the other, an eclipse with no sun involved, one dead world darkening another, right above your head. It sounds like a gift, a richer, brighter night, but look closer at what actually lives by that light. Corals along the reefs spawn on a single signal, the light of the full moon, all of them at once, on one night of the year. Sea turtles haul themselves onto the beach and read the brightest horizon to find their way back to the sea. Moths steer by it, predators hunt by it, and their prey hide by it. Whole species have built their breeding, their migrations, their entire sense of time around one steady, unchanging moon. Give them two, out of sync, unpredictable, always shifting, and every one of those clocks breaks at once. Reefs that spawn on the wrong night, into empty water. Hatchlings crawling the wrong way, inland, into the dark. A living world that has kept time by the moon for hundreds of millions of years, suddenly unable to read its own sky. The moon was never just a light we looked at. It was a clock half the planet was quietly setting itself by. But this is only the calm chapter, because one of those two moons is not holding its orbit. It's slowly falling toward us. And there's a line in space you never want a moon to cross. It's called the Roche limit. Get a moon close enough to a planet, and the planet's gravity pulls harder on the near side than the far side. Hard enough to tear the moon apart, not with an impact, just with tides. None of this happens overnight. A moon drifting close enough to cross that line takes ages. But once it does, the ending is the same. It shreds into rock, gravel, and dust. And that dust doesn't fall straight down. It spreads out, wraps around the Earth, and flattens into a ring. For a while, Earth would have rings, pale bands arcing across the sky, catching the sunlight, casting a thin shadow across the planet. Beautiful, from a distance. Up close, it's a bombardment, and this is nothing like the meteor storm from the night of the break. That one was brief, brilliant, over in days. This one is the opposite. Slow, relentless, effectively endless. Because a ring is not stable forever. Piece by piece it rains down, chunks of former moon burning through the atmosphere, night after night, generation after generation. Not one shooting star, thousands. A sky that flickers and streaks and never quite goes quiet. Some pieces small, some very much not. The glowing spectacle overhead slowly becomes fire falling to the ground. Every clear night, for longer than all of recorded history, the sky would rain down pieces of a world that once hung there whole. Now bring it down to the water. Every day, the ocean rises and falls, the tides, and the moon is what pulls them. Its gravity drags the seas into a bulge that follows it around the planet. So what happens when the puller breaks in two? If the halves stay close, the tides hold, roughly. But if they drift apart, to different distances, different sides of the sky, their pulls begin to fight. The clean, predictable rhythm the oceans have kept for billions of years breaks down. Tides that arrive at the wrong times, bulges pulling in two directions at once, coastlines that flood when they shouldn't and drain when they shouldn't. Picture a harbor where the tide climbs twice as high as anything it was built for, then pulls back to bare seafloor for miles by the next morning. Boats lifted over the docks, then left stranded in mud, on a schedule no one can predict. The oldest rhythm in human life, the one every coastal city quietly planned around, simply stops making sense. And underneath the water, something slower is happening, to time itself. The moon doesn't just move the seas. That same tidal grip has been gently slowing Earth's spin for billions of years, stretching our day out second by second. Tear the moon apart and scatter its mass, and you reach straight into the machinery that sets the length of the day. But even that isn't the thing that would end us. The real danger from a broken moon is the one you can't see at all. Here's what the moon has been doing this whole time, without anyone thanking it. It has been holding us steady. Earth is a spinning top, and it's tilted, about 23 degrees. That tilt is why we have seasons. And a spinning top, left alone, doesn't hold its angle. It wobbles. Earth would too, swinging over millions of years, tipping so far that the poles could point almost straight at the sun. The only reason that doesn't happen is the moon. One big, steady mass, holding our tilt almost perfectly still. It is the anchor that keeps our seasons mild and our climate calm enough for life to build something on top of it. Now, take that anchor and break it. Scatter it into halves, or a ring, or a smaller reformed lump. The steadying grip weakens, and the Earth begins, very slowly, to wobble free. Not in a day, not in a year, but over millions of years, the tilt starts to wander. And when a planet's tilt wanders, its climate doesn't just change, it lurches. Ice where there were tropics, deserts where there were oceans of grain, seasons that swing from nothing to unbearable and back again. The moon breaking wouldn't kill us with fire from the sky. It would kill us with silence, by quietly letting go of the one thing it had been holding steady all along. So, come back to where we started. You, standing outside, looking up at the moon. One piece, gray, boring, almost. The thing you never think about because it has simply always been there. But it was never just a light in the sky. It's a shield that takes the hits meant for us. It's a hand on the ocean, setting its rhythm. It's a clock, slowing our days. And it's an anchor, holding our whole world at the exact angle life needs. Split it in two, and you don't just lose a pretty face in the night. You pull the keystone out of everything down here. The tides, the seasons, the length of the day, the fragile balance you were born into and never noticed. We look up at the moon and see something dead, something finished. It might be the most important thing keeping us alive. So tonight, step outside and look up. Find that quiet gray rock, whole and steady, exactly where it's always been. And now you know what it would cost, if it ever came apart. If this one got to you, subscribe. The universe is quietly terrifying, and we're only getting started.